Hi students, in today's video lecture we are going to see two different topics. One is the common elements of a generalized measurement system. Okay, this consists of certain common elements which any measurement system consists of, and with the example of such a measurement system we are going to see how the input signal is going to be converted into the output signal. Okay, this is first topic. And the second topic is whatever measuring system we are going to have, we will have 5 basic elements. So what are those basic elements we are going to see? Kindly make note that both the topics are slightly different and both should not be confused while the question is being asked in the exam. Okay, if they are going to ask the question as elements of a generalized measurement system with an example, you definitely need to draw this block diagram and you need to draw another diagram which I am going to show in the next slide, and you need to explain. If they are going to ask what are the various elements of a measuring system, then you need to write those 5 basic elements. Kindly make a note of this. Okay, going into the topic, first we are going to see the first topic, that is common elements of a generalized measurement system. We have 6 different elements in a generalized measurement system, that is element number 1 primary sensing element, element number 2 variable conversion element, element number 3 variable manipulation element, element number 4 data transmission element, element number 5 data processing element, and element number 6 data presentation element. Apart from this, we have the input signal which is being received from the physical quantity for which the measurement is to be done, and the output signal which is being displayed in the display unit through analog or digital form in the human readable format to the observer. Okay, this is the output signal and this is the input signal. Okay, so these are the 6 different elements that is available in a generalized measurement system. Okay, we will be seeing each and every element now. Say for example, we have an input signal that is coming from a physical quantity which needs to be measured. Okay, we are not going to consider any example in this particular explanation now, and later we will consider an example and explain again so that you will have a better understanding. First, the input signal is being sensed by an element. Okay, this particular sensing element which senses that there is an input signal from the quantity to be measured is called as the primary sensing element. Okay, next is this primary sensing element will sense the input signal in one particular form. Okay, but will that form be understood by the instrument itself? No, definitely not. Or is that signal strong enough for the instrument to manipulate? Definitely not. So we need some manipulations in between, right? So for that purpose, what we are going to do is we are going to convert this primary input signal which is being sensed by this sensor into another converted signal by an element called a variable conversion element. Okay, here the input signal may be of one form and this converted signal may be of the other form. Say for example, if this input signal is of some mechanical form, this can be of an electrical form, or if this is of an electrical form, this can be of a mechanical form. Whatever it is, we will see with an example, you will better understand. Next is the variable manipulation element. So what this element does is this signal, again it checks whether the converted signal is strong enough to be read or not. If it is not strong enough to be read, then it amplifies the signal, that is, it manipulates the signal so that the instrument can perform some process and give the output. So this conversion from the converted signal into the amplified signal is being done by the variable manipulation element. Okay, now this amplified signal is fed into the data transmission element. So the purpose of this transmission element is purely transmission only. It doesn't change the form of the signal. It just transmits the amplified signal from here to this processing element. Okay, it is just like a carrier, just like a wire carrying current. Okay, this data processing element is nothing but the mother of the processor. This processing element is going to process this amplified signal which is reached over here, and after processing it gives some other result in the form of a processed signal which is mentioned over here to the data presentation element. Okay, here it is going to process the amplified signal. After certain processing is carried out, the data presentation element is being fed with the processed signal, and this data presentation element is going to show the output signal in the human readable form in the display to the observer. Okay, if it is an analog form, it is going to show it as an analog. If it is a digital form, it is going to show in the value of numbers. Okay, this is how this transmission happens. So again I am repeating, we have 6 different elements. One is primary sensing element, variable conversion element, variable manipulation element, data transmission element, data processing element, data presentation element, and finally the output signal is being fed to the display, and here the input signal is being sensed by the sensor. Okay, so 6 elements. Please make a note that these 6 elements should not necessarily be in the same order which is mentioned over here. Some measuring instruments might have 2 or 3 data processing elements, might have 2 or 3 data transmission elements, might need 2 or 3 variable manipulation elements, and might need 2 or 3 variable conversion elements also. It also requires more than one sensor to receive the input signal. So in such cases, we will have a combination of different elements, but still when we are going to categorize it, we will have the category only as these 6 elements, that is primary sensing element, variable conversion element, variable manipulation element, data transmission element, data processing element, and finally data presentation element. Okay, now we will see with an example. Okay, consider an example of pressure type thermometer, otherwise called as the board on tube method of measuring the temperature. Okay, here the pressure type thermometer, please note that here we are not going to measure the pressure, we are going to use the thermometer, we are going to determine the temperature using the pressure. Okay, this is very, very important. Okay, so what does this do? This is the instrument whichever we are going to use, the setup of the instrument. Here we have the bulb, here we have the stem of the thermometer, and this is the adjustable connection, and here we have the armor or the tube which is connecting the thermometer with the board on tube, and here we have the socket, and here we have the board on tube. You see this U-shaped blue color tube, this is called as the board on tube. Okay, and this purple color graduated scale over this U-shaped tube is nothing but the graduated scale, and this is the pointer. Okay, so this is the leveraging mechanism, this is the link which converts the motion, and this pointer is going to move from smallest value, that is 0, to some maximum value. Okay, so this is how the thermometer, this particular pressure type thermometer, is constructed. Okay, what is the principle behind this working? It is very simple. We all know that liquids will expand or contract in proportion to the temperature. Okay, and we also know that the enclosed liquid, when partially filled, will create definite vapor pressure in proportion to its temperature. These two are the basic principles, and covering these two principles, we have the universal gas law, that is PV equal to nRT, where P refers to the pressure, V refers to the volume, R refers to the universal gas constant, and T refers to the pressure. Sorry, T refers to the temperature. Okay, so what does these two principles refers to? Nothing but the red color inside this bulb refers to the liquid inside the thermometer bulb. Okay, consider we have seen a thermometer with mercury inside it, right? The mercury will not be filled for the entire bulb, it will be filled only at the bottom of the bulb, right? So that particular liquid is referred here as red color. Okay, so whenever we are going to apply some temperature, based on the temperature, the pressure is going to vary. That is, the vapor pressure which is filled in this empty space is going to vary, and this liquid is going to rise accordingly depending on the temperature. Based on this rise, what happens is the vapor pressure, that is the vapor which is filled over here, will move up, and this tube is going to be moved in accordance with this movement, and this movement is going to affect this expansion in this Bourdon tube. This expansion in the Bourdon tube is going to affect the levering linkages and the gear wheel, and accordingly this pointer is going to move. This is how this generalized measurement system in this pressure type thermometer is going to work. Okay, I am repeating again. Okay, consider a beaker with some liquid whose temperature is to be measured, and this thermometer is placed inside the liquid. Okay, so that this tip is touching the liquid. Okay, what happens is, based on the temperature of the liquid inside this bulb, the red color liquid inside this bulb is going to expand or contract. Because of this expansion or contraction, there will be a difference in the vapor pressure of the gas which is filled over here. Okay, what happens because of this difference in vapor pressure is, this tube will accordingly expand or contract. When this tube is going to expand or contract, automatically this Bourdon tube in turn is going to expand or contract. Based on this expansion or contraction, what happens is, this linkage is going to move accordingly, and this gear wheel is going to get engaged with this leveraging linkage accordingly, and this pointer is going to get moved from the 0 to the maximum, or in the reverse direction. So based on this scale, we will be able to find out the value. Okay, so once we know the value of the sometimes this value will be read as pressure, and this pressure, when we are going to use it in some formula, we are going to get the temperature. This is how this particular generalized measurement system works. Okay, now comparing this with the various elements whichever we have discussed in the previous slide, we will see. So first we talked about the primary sensing element, right? So this bulb, the liquid inside this bulb is going to act as the sensor. Okay, this is the primary sensing element which senses the temperature. Okay, next, this temperature which is sensed by this red color fluid inside the bulb is going to get converted into a form of pressure, right? So this pressure conversion is taking place inside this tube because of the gas which is filled with vapor pressure difference which is created inside this bulb. Okay, so this here we are going to get converted the input signal into a converted signal, that is the pressure. Temperature signal is converted into a pressure signal. So this is what we call as variable conversion element. Okay, next is, we are going to transmit the pressure from this to this, that is the measuring device, correct? So this is where we are going to have the data transmission element. Okay, whatever I have told before, here it is not in that order whichever we have seen in the previous slide. Here we have a slight data transmission element over here. Okay, after the data gets transmitted, what happens is the value converted signal enough for reading? No, it needs some magnification, that is variable manipulation is required. That is the reason we are going to use this Bourdon tube which is blue in color. Here, based on the pressure, this Bourdon tube is going to get magnified or expanded. So this is where we call it as variable manipulation element. Okay, once this is manipulated, this is where we are going to process the data. That is, the linkage is going to move according to the expansion. This linkage which is connected with this gear wheel through this pinion is going to move the pointer. So here, this is where we are going to convert the variable manipulated signal, that is amplified signal, into a processed signal. This processed signal is given to this pointer through this gear. Okay, and this processed signal is being read over the data presentation element, that is nothing but the graduated scale, and the observer will be able to see the scale. All these are hidden inside the instrument itself. Okay, Now we have seen the different common elements of a generalized measurement system with an example, that is the pressure type thermometer. Next we will be seeing the second topic, that is basic elements of a measuring system. As I already told you, this is a different topic which is compared to the previous topic which we have considered today in our video lecture. Both questions should not be confused while writing in the examination. Okay, in this topic we are going to see the different elements of a measuring system. So in any metrology or a measuring system, we have 5 different elements. That is standard S, workpiece W, instrument I, person or people, that is nothing but P, and environment E. Why we are using these short terms is just for remembrance. We can call this as swipe. That is, the elements of a measuring system can be called as swipe. S for standard, W for workpiece, I for instrument, P for person or people, and finally E for environment. Okay, why we are considering only these 5 we are going to see in the next slide. Because standard, the most basic element of measurement, is a standard without which no measurement is possible. We already know this. When we have seen how to measure, generally we have told that we are going to compare the unknown quantity with a known quantity, correct? This known quantity is nothing but the standard. Only if we are going to have a standard, we will be having an element for comparison. Okay, so that is the reason we are going to have this standard as the first element of measuring system. Next, we have a standard, that is known quantity. Next, we need to have an unknown quantity for measuring, right? This unknown quantity is nothing but the workpiece. Once the standard is chosen, select a workpiece on which measurement will be performed. Okay, this workpiece has to be chosen, and this workpiece is going to differ for the same standard. Different workpieces can be used, okay, based on the application. Say for example, a rectangular bar can be used for measuring the length using a scale. Instead of a rectangular bar, you can also use a triangular bar. You can also use a square plate. You can also use a linear unknown sheet whose length is to be determined. So whichever we are going to use, that is considered as the workpiece. Okay, this is the second element. The third element is nothing but instrument. Okay, we have the standard, we have the workpiece, then we need some comparison process, right? This process is being given by the instrument. Okay, and this is nothing but then we select an instrument with the help of which measurement will be done. Okay, we have a lot of instruments that can do the same job. Okay, we can use a ruler for measuring the length, we can use a vernier caliper for measuring the length, we can use several other instruments for measuring the same length, correct? So which instrument we are going to use for a particular application is the challenge. So this challenge is again going to be based on the accuracy we need and the application we are going to apply for. Okay, so this instrument is the third element. Next, we have standard, we have workpiece, we have instrument. Who is going to do the measurement? A person or an automated machine with the help of a person, correct? So this person is definitely inevitable. He or she needs to be present for a measurement to be done. Okay, and this measurement, even if it is done using an automated machine, a person has to be there to sit and see whether the value which is being recorded by the particular automated machine is correct or not. So definitely this person need to be involved. Okay, the measurement should be performed under standard environment by the person. And finally, the fifth element is nothing but the environment. And lastly, there must be some person or mechanism to carry out the environment and under standard operating environment, that is conditions. This is where you consider this environment. Okay, so this environment is nothing but the conditions, that is the temperature, the pressure, what humidity should be inside the lab for the measurement. All those things are the environmental conditions. Next, we are going to see the factors affecting the accuracy of the measurement system. We have seen the various elements of measuring system, right? Next we are going to see how these 5 elements are going to have the various factors being affected. Okay, so first the factors affecting the calibration standards, that is the standard S, factors affecting the workpiece W, factors affecting the instrument, factors affecting the person, and finally the factors affecting the environment. We are going to see all these 5 factors, whichever these elements are going to get affected. Okay, first the factors affecting the calibration standard, that is the standards. Coefficient of thermal expansion of the standard, calibration interval, stability with time, elastic properties, geometric compatibility, all these factors are going to affect the standard. Say for example, the coefficient of thermal expansion of a standard might vary depending on the temperature. Similarly, the calibration interval, between what intervals that need to be calibrated. Should it require 1 month, or should it require 2 months, or should it require 1 year or 6 months? This calibration interval. And stability with time. Again, this stability is related to calibration. This stability is going to be within the acceptable limits whenever the calibration, whenever we are going to have the check the stability of that particular standard between the calibration interval. And the elastic properties, nothing but the Young's modulus, bulk modulus, and the ultimate tensile strength, or the other modulus properties, that is the elastic properties of the standard, is going to vary with respect to temperature, pressure, or the working atmosphere, or the usage of the standard with the instrument or the workpiece, whether it is going to physically contact the workpiece or physically contact with the instrument, something like that. All these are to be considered. Then the geometric compatibility, how far the environmental conditions are going to change the geometric dimensions of the standard. If the standard is of a cuboid, say for example, if the standard is of a cuboid geometry, and with the respect to temperature or pressure, if it is going to change, then we cannot use the standard under those conditions. So we need to know all these things before going to use the standard for a particular application. Similarly, we have the various factors affecting the workpiece are cleanliness, surface finish, waviness, scratch, surface hidden geometry, elastic properties, adequate datum on the workpiece, arrangement of supporting workpiece, thermal equalization, etc. That is, the list goes on. Okay, what is cleanliness? The workpiece whichever we are going to measure should be clean enough so that it does not damage the workpiece itself, or it does not damage the instrument, or it does not damage the standard, whether if it is in physical contact. Then similarly, we need to know what is the surface finish, what is the waviness of the workpiece, what is this, whether there are any scratches on the workpiece, whether there are any surface hidden geometry. Say for example, and over the surface it looks good, but 1 layer or 2 layers below the surface, the workpiece may not be of the required geometry. These can be done using various non-destructive testing methods, and based on that only we will be able to identify whether there are any irregularities inside the surface, that is beneath the surface. Okay. Similarly, the various elastic properties of the surface workpiece, and the adequate datum on the workpiece. Adequate datum in the sense adequate standard which can be fixed on the workpiece. Okay. And next is the arrangement of supporting workpiece. Supporting workpiece, if there are any, if the workpiece is of very small size and if it cannot be held by the instrument, then we are going to have supporting objects for the workpieces. Whether that supporting objects are of correct cleanliness, correct surface finish, it is going to affect the it is going to put scratches on the surface of the workpiece or not. All these things to be considered. Then the thermal equalization, that is the workpiece, the standard, the instrument, all these three should be under the same thermal conditions. If it is going to change, then what happens is only till acceptable limits the instrument will work properly, otherwise it is not going to work. So this thermal equalization is also important. Next, we are going to see the factors affecting the instrument. we have several factors, that is adequate amplification for accuracy objective. Yeah, definitely we know about this, right? Amplification is required to the adequate level. Without amplification, we cannot read the weak signals. We cannot convert those weak input signals into output. So for accuracy perspective, for accurate measurement, if accuracy is our objective, then definitely we need to have adequate amplification. Next, scale error. Scale error should not be there. Then effect of friction, backlash, hysteresis, zero drift errors, all these should be avoided to the maximum, or at least should be within the acceptable limits. Then deformation in handling or use. That is, I already told you, whenever we are going to use the instrument under for different applications under environmental conditions required. That is again going to differ from application to application. So that time what happens is the instrument might be subjected to deformation. So all these deformation should be considered. Then calibration errors. Calibration errors should be identified, that is detected, and those should be rectified before using the instrument for measurement, any measurement. Then the mechanical parts. Even in the example of the pressure type thermometer, we have seen the linkages, pinion and gear, where we have the mechanical parts, and those mechanical parts will start getting worn out due to the usage, correct? So those things have to be considered, and they have to be replaced where it is required, wherever it is required. What is the repeatability and readability of the instrument? This is definitely a very major factor that is going to affect the usability of the instrument. Repeatability is nothing but the same value should be repeated by the instrument whenever we are going to measure again and again. Say for example, if we are going to place 10 kg on a weighing scale, it has to simply say 10 kg each time we are going to place. That is within the acceptable limits, 9.8, 9.9 or 10.1 or 10.2, whatever it may be. But it should not go beyond the acceptable limit. If it is going to go beyond the acceptable limit, then go for calibration. Then readability. Readability is again nothing but the refers to the required amplification. If there is required amplification, adequate amplification is available in the instrument, then definitely readability is not going to be a problem. We will definitely able to get the output in the human readable form. Then contact geometry for both workpiece and standard. Again, that is the physical contact. Because of the physical contact with the workpiece and the instrument, and in standard and the instrument, is there going to be any changes in the geometry over a period of time? That needs to be considered. These are the various factors affecting the instrument. Next is the factors affecting the person. Definitely a skilled, trained person is required for doing any experimentation or any measurement. Without any skill or training, we will not be definitely able to do the measurement. That is for industrial standards. Okay, next is sense of precision appreciation. Okay, precision, whether the device is precise or not, whether the instrument is precise or not, that sense of appreciation will come to a person only based on the skill. Okay, next is ability to select measuring instruments and standards. Again, I told you there will be a set of measurement instruments and standards for a particular application. Which instrument is to be used, which standard is to be used, that definitely depends on the person. Only the person has to decide. The skill of the person will decide. Then the sensible appreciation of measuring cost. What is the measuring cost? Based on the instrument, based on the standard, based on the environmental conditions, the measuring cost will vary. So based on the skill of the person, this measuring cost is going to be at the most minimal as possible. That is what the industry expects also. Then attitude towards personal accuracy achievements. That is, we should have the right attitude towards the personal accuracy. That is considered. Then planning measurement techniques for minimum cost and the requirements. All these are going to be the factors affecting the person. Next is the factors affecting the environment. This is as simple as the temperature, humidity, clean environment, minimum vibrations, adequate illumination. Light is also a source of energy, and proper lighting should be there for some instruments to properly work, and for some instruments to read the instruments from the display, we need proper lighting. All those things will be considered here. Temperature equalization, thermal expansion, heating elements, manual handling, all these are required. So with this we come to the conclusion of today's two topics, that is common elements for a generalized measurement system and the various basic elements of a measuring system. Okay, we will be seeing the types of methodology in our next lecture. Thank you.